Welcome to an ultralight airplane design video from the Ultralight Airplane Workshop. You found part 3 of a little 3-part mini-series that I'm doing on constructing a mock-up of the steel tubing frame of the UWS-4 Ultralight Airplane. If you're not familiar with the UWS-4 Ultralight Airplane design, I'll put a link up here in the upper right-hand corner you can go to, and that'll be a playlist for the various videos that we've made on the design of the UWS-4 Ultralight Airplane. Now, if you've only missed parts 1 and 2, let me talk a little bit about what those are, and we'll also put a link up in the corner. In part 1, I went over what I expected the build to be, the reasons for the build, what I expected to learn from the build, and how I plan to do the build. And like I said, I'll put a link up here in the upper right-hand corner that you can go to see that video if you haven't seen it already. Now, in part 2, that was pretty fun. That was a whole lot of video recording, but I recorded the build of the mock-up. Now that was a time-lapse video. Before I crunched it down by a factor of 10 to make it run faster, it was around 240 minutes long. At the end of that video, I went over a little bit about the techniques I used in the build, how there were similarities between the way I used the stick frames and what a welded tube frame would be, and I talked about some of the things I should have done slightly different. And again, I'll put a link up here in the upper right-hand corner you can go to if you have not seen that video yet. But now we're in part 3, and in part 3 we're going to analyze this frame. So a quick outline of what this video is going to be. I'll do a front-to-back look at some of the features of the airplane, features that we came up with based on Dan Raymer's book. And I've talked about Dan's book a lot, that's what we used to base our design on. And then we did configuration of the frame in the program OpenVSP. So using Dan's book and OpenVSP, we came up with a design for the structure of the fuselage of the airplane. But I wanted to verify that what we came up with was really going to be practical. So we will do a front to back little explanation, a little walkthrough of this frame, talking about some of the features of it. Then we're going to climb into the frame and see if all the dimensions and the design criteria that we used really meets with real life expectations. Now in the last part of the video, I plan to do something that I talked about quite a bit on both the first and second parts of the video, which is do a rollover test. See if I can climb out from underneath this frame when it's upside down. Now I've already turned this frame upside down and looked at the size of that opening, and I'm skeptical about whether I can crawl out of there. But we're going to give it a try. Now let's get to it. Let's start at the front of the airplane talking about some of the features of the frame and move our way backward. Let's start up here with the heel pads that I've installed. These heel pads are a place for me to rest my feet as I'm doing my analysis. It helps me spread the weight of my foot around to these 3 different tubes here. Well, they're supposed to be tubes. I put a little screw here that I can put my mock control stick over so I can play around with moving around, see what the movement's going to be. Next thing will be the instrument panel. So this is a mock-up of the instrument panel. Now this isn't quite true to the actual outline that I have in OpenVSP. This really should not be straight up and down here on these corners. This should already be at a slight angle coming in. So this little curve up here will be a little bit cut off, but the height is still correct. And I've hot glued a little ledge in here that I can put my phone on so I can do controls with the cameras a little bit later on. Next area is the seat here. Now, the seat is a little bit more interesting. At least it will be in the future. Now, right now I have some foam padding on here. This isn't necessarily representative of what I will have in the future. But there's some 1.5 inch, 1.25 inch here on the back, and there's some 4-inch here on the bottom. Now the foam here on the bottom is actually resting on a little riser that I made out of some insulation foam. It was a whole bunch of scrap foam that I had laying around. The idea behind this seat bottom is I want it to be able to absorb the energy of a flat impact on the airplane. So what it should do is something similar to bicycle helmets. Bicycle helmets that have that expanded polystyrene bead in it. It's a one-time crash helmet. In other words, once you crash with it, you have to replace it. The idea is that if you do have a flat impact with the ground and the weight of your body comes down onto this, it will crush down to absorb some of that energy. So the idea to do that is to drill holes in the bottom of it so that it will have the correct amount of crush. So I want to be able to absorb up to 9 Gs If you remember, that's what we talked about in one of those safety videos. I need to be able to absorb up to 9 Gs vertically. So what I'll do is I'll put enough holes in the seat bottom for that to work. So at 9 Gs, if I impact flat, it should just come down to where it crushes down fairly flat. Now, any more than 9 Gs, of course, it would crush flat, and then it wouldn't crush anymore, so more Gs would actually be absorbed up into the pilot's body. At less than 9 Gs, it won't crush quite as much. So what I'm going to have to do is some experiments to find out how much force it takes to crush this foam, and then I'll remove enough foam to do the 9 Gs with a certain weight of pilot. Now underneath we have a board that in the real airplane will be something similar, and it will be used to transfer load from the airplane into the seat, into the pilot, or vice versa, from the pilot into the seat, into the airplane. This is the bolt for the crotch strap on the 5-point harness. Here's the right side and the left side. We'll talk a little bit more about that here in a moment. Here is the seat back. Right now it's just a simple piece of really thin wood that's hot glued on there. And then we have the shoulder straps attached back here at a hard point. Now, the last thing to talk about before we climb into this bird and start doing some analysis is back here. I'm going to use this board back here as a stand-in for the wing. So I'll step up onto this board and then into the airplane, onto the seat. So that's how we'll get in and out of the airplane. Now the top of the wing will actually be up about here. Leading edge will be about here. So this is kind of halfway between the top and the leading edge, which is probably about where I'll be stepping. So this is probably pretty close to the right height. Maybe just a little bit higher, but this is pretty good. Let's climb into this beast and do some analysis. It's been a few days since I recorded that last segment, and in the meantime I'd done some work with OpenVSP, and looking at the wing I realized that where I had placed this board, kind of representing the top of the wing, or where I would step on the wing when I was climbing in and out, was wrong. It actually needed to come up pretty darn close to the top of the wing. And part of the reason for that is this airfoil is inclined at 5 degrees angle of attack in order to get the correct lift at cruise, and that moves the top part of the wing, or the highest point of the wing, forward a little bit. And so I'm actually going to be stepping on that highest point when I'm getting in and out. So I've raised this up close to where the top of the wing would be. Now let's climb in and do some more analysis. Now I've set in the mock-up several times, and at least in the short amount of time I've been setting in it, the seat is pretty comfortable. But we'll cover that a little more here in a few minutes. Now, as we did before when I was talking about the features of the mock-up, let's start at the front and work our way back. So up on the pedals where they're going to be, I'm trying to set in here as I think I will be setting when I'm flying. So I'll need room for the stick to move, so I've got my knees out to the side. I think I've got my feet in a fairly comfortable neutral position, like if the rudder pedals are in neutral. So now I want to imagine applying right rudder and left rudder and moving my feet like that. So if I do that, I would say my heel, see with my leg going to full extension, if I do that, okay, so I would say that where my heel is contacting at the front of the lower longerons, I really don't want my heel to contact. And I'd like to be able to possibly allow people that are taller than me with longer legs to fly the airplane. So it's just possibly barely right for me, but with longer legs, I don't think it would work. I think it would be too short. Or they would have to have their knees up higher, which could work. But I would like to allow someone to have their legs stretched out a little bit more if they want to. So what I think I'm going to do is the very front part of the airplane, I'm going to move forward, let's say 2 inches. I think I'll add 2 more inches of length at the front. And I would say that angle is probably about right if I'm doing toe brakes. It's about the right angle, so I think the angle there at the front is for the frame is about right. Okay, let's look at the stick, the control stick. Okay, my mock control stick is down here on the ground. I've got a screw down here. I'm going to put the end of the control stick in. And now we can start playing with this. So forward and back. So I want to try to feel, okay, in the neutral position, with my arm feeling like it's in the neutral position. So the stick is close to straight up and down, which I like, because I'm probably going to use something like a push rod. And going forward and backward from that neutral position, that means that I'll have about the same amount of swing back and forth. If it was way back here in the neutral position and I moved it back, I wouldn't have as much movement in that push rod as I would pushing it forward. So I like that it's close to vertical. It could come back about an inch and a half if I wanted to, if I really wanted to be completely vertical. So that's good to know. Now, if I remember correctly, in the video where we were talking about the control stick and the seating, trying to get all that figured out, we needed 7 inches left and right from neutral movement. Let's see if we've got that. All right, so from a neutral position, let's move it to the right, like about 5.5 at the top of the stick. So I'm not getting 7 inches like they recommend. Now the only way to get 7 inches is to have my knees come out even farther, but I think that would be uncomfortable. Let's see, what if the stick is farther? Well, I can get 6 inches there at the widest part where my knee is. So my hand in the neutral position, or what feels like a neutral position, won't give me my full throw, at least not a throw of 7 inches. Now if I remember correctly, 5 inches forward and 7 inches back. Well, I can get way more than 7 inches coming back, it looks like. So let's try that. Oh yeah, I can easily get 7 coming back. Now, let's try forward. See, I'll start at the 5-inch mark and move back. So there's neutral. So comfortably, I'm getting about 4 inches of movement forward. Now, let's say 4.5, about 4.5. So my arm fully extended. So I could change that by having the stick come back just a little bit more, having my neutral position be just a little bit closer to me. So I could easily then get that 5 forward and 5 back. So it looks like about 2.5 inches is probably what I should use for neutral. Now that gives me even less left and right movement if I do that, just because of the angle of my legs here. So I'm going to give a little bit of thought then to possibly widening this spot, maybe another inch out on each side. That would let me move my knees out. This tube right here is what's preventing my leg from coming out further. So moving an inch out would give me enough leg room then for 7 inches if I really want that. So that's something to think about. That would give me a little more instrument panel room. So there's that. And speak of instrument panel, let's talk about that. So the height I have the stick right now, it goes underneath the instrument panel with about 1.5 inches to spare. So that's just barely enough. If I should happen to have my hand or my thumb over the stick, I can still clear that. So I really like that. Okay, now let's figure out some other aspects of the instrument panel. Let's first figure out distance. Now, if I remember correctly, they mentioned a distance of 26 to 28 inches. And I think I wanted 26 inches. Let's figure out if that's fairly close to accurate. So I'll stick my measuring stick up here. Pretend I'm flying, looking forward. About there. So I got about 25.5 inches. So that's pretty close to right. Now, let's think about whether I have some buttons and some dials, things I can configure on here. So it's easily within reach, no problem there. So if I wanted to think about reach, at least with push buttons, I could go another, if I really wanted to, I could go another 5 inches or so forward. But that would be just with touching and pretty close to a full arm extension. But what about turning a knob? That's going to be a little bit shorter because you've got to use your thumb, including your index finger. So that's going to shorten it up a little bit, and you're also going to cock your finger a little bit. So that's a little bit closer. So at full extension, that then becomes about 3.5 inches. Don't know if I really want a full extension. I'd like for it to be a little more comfortable. So let me just reach up here and feel what looks or feels comfortable. About like that. So about 2 inches more actually feels more comfortable, because doing it here, my elbow feels like it's too close to my body. That doesn't feel comfortable. I'd like to have it out just a little bit further. So I think I'm going to move it out 2 inches forward. Now that's actually going to work out pretty well with the 2 inches down at the foot pedal area. So I can leave the dimensions of the front part the same, just move it forward 2 inches. And then, of course, the inch on each side we were talking about for possibly giving myself some more leg room so I get more stick movement. Now, this isn't a big instrument panel, but it's an ultralight. I don't need a lot of instruments. Now, what I'm thinking of doing is putting 2 7-inch LED displays in here. So one would be all the engine instruments. The other one would be everything else, like airspeed, angle of attack. And I think, at least the way I made this one, I think I can get 2 7-inch displays in here. But as I mentioned before, this is probably too rounded or sticks out a little bit too far. But by adding another inch out here, I think that will then move this farther out. And so I think I can still get easily 2 7-inch displays in here. And that also leaves some room for other things like switches or possibly a couple of analog shaped dials and fuses, of course. Now, I've already mentioned the seat a little bit. This 4-inch foam is really too thick. I've got, what, an inch, at least another inch of padding under there. So this padding is really too much. But it sets my height. So let's find out if this height where my eyes are gives me the sight over the instrument panel that I want. Now, if I remember correctly, we didn't want the bottom of the instrument panel to be more than 35 degrees down from level. And the top of the instrument panel, I was going for 20 degrees down from a level. And I think they recommended 15 if you could do it. So let's see what we got. I happen to have a nice little level gauge here. So let's turn that on. It's 58 degrees in here, a little bit chilly. All right, I got a little hold switch. So what I'm going to do is sight down this and look at the top. I'm going to try to get comfortable. Flight position, look down at the top, press the hold. I got 19.6, so I have 20 degrees. So that actually worked out really good. So my head is at the right height, so maybe I do want to keep this cushion height. Let's look at the bottom of the instrument panel. That one's going to be a little harder to do a good job on, so let's look down there. I got 35.2 degrees, so that actually worked out right. And speaking of seats, let's get the seat belt hooked up and see what that's like. I've only hooked this seat belt up once before, and I was a little bit clumsy, but let's go ahead and get her done. Well, the belt itself is pretty comfortable. I've already adjusted it when I got in and tested it out once before. So it's pretty comfortable, especially over the shoulder. I really like this latch. It's a one-handed latch. All you gotta do is flip this little lever down here. I'll show you a picture of it. and 4 of the 5 belts come loose. Now you may have noticed as I was hooking it up, the crotch belt and this left shoulder belt don't really want to latch right. So I don't think I really want to use this seat belt in real life. I'll use something similar. I like this latching mechanism. Well, at least I like the release on the latching mechanism. It's not latching very well, but it releases really well. I think I might have mentioned before that this seat belt is extremely heavy. All the fittings on here are made out of steel, at least something similar to steel. And I would really rather have some of it be either titanium or aluminum to make it lighter. For example, these attach points down here, they could probably be made out of a lighter metal. And with the shoulder harness, I would probably leave the latch all steel just because it's going to have wear on it, and steel's going to wear far better than aluminum will. But these could probably be replaced, and we could probably go with 2-inch instead of 3-inch wide belts, and of course that would save some weight too. But if I do that, there's going to be some extensive testing, especially with 9G loads on it, to make sure that any replacement parts that I come up with are actually going to work. Now this does seem to hold me fairly well, and I definitely want it to hold me when I go upside down. Now sitting here, it's kind of hard to judge that, but I think it's going to work. Well, let's move back just a little bit more and think about headroom here. Now, I got a little helmet to do some testing with here. So let's work on putting the head back. How does that feel? Well, I'm a little surprised. So flying, I would be about here. So there's only about 1 inch of space there. I was thinking about putting like a foam backrest for the head to go back against. That's just about right. Now what about headroom? So I'm going to have to look at it on camera to be sure, but oh heck, we got something here we can test with. So let's use this to figure out what the angle is. Is the top of my helmet above or below this? I think it's below, but I'm not positive. Let's find out. This says I'm 4 degrees below, so I'm just barely below that spot. And if I put a shell on this fuselage, which I hope I have enough weight allowance to do it, the shell will go up a little bit higher, about 1 inch higher. So that's just barely enough height. So that's actually less space than I thought I would have. So I really don't want my eyes to come lower. So I need to give a little bit of thought to possibly raising this rollover just a little bit. So I got a little more headroom. So I think it probably would be good to raise this bar a little bit if I keep the instrument panel and the seat at this height. Now let's talk about potentially lowering the instrument panel. Now if I kept my control stick at the same height, that would be a problem. I would be hitting my control stick. So I could potentially shorten my control stick. Now if I do that, I kind of like that I can actually pull my knees completely out and not have my knee hit the instrument panel. But if I lower it down, I can only lower it about 1 inch before I'd start running into problems. Now someone slightly taller than me would start hitting their knee trying to do that. Now that's not typically how you get out of the airplane. So I probably shouldn't really be giving that consideration, but I really like that. So I'm going to give some thought to raising this rollover protection. I like this seat back angle. If I remember right, we were talking about, what, a 12 degree from vertical angle? I'm not sure if that's what we ended up with, but I like it. I think it's going to be comfortable flying. So I like that. One thing I'm not fond of is how high this bar is. If I want to look down below the aircraft, I can't see quite as directly below me as I would like to. And let's talk about fit on the shoulder here too. Now my shoulders aren't that wide. I've got about 1.5 inches of clearance on each side. Someone with wider shoulders is certainly going to be pretty tight in here. Now the fuselage is going to round out around a little bit further out. It's going to be touching roughly here. It's going to round out a little bit, about 1 inch or 1.5 inches. It'll be touching here at this corner. So there's going to be some more elbow room down here because this will bulge out a little bit. I'll have to give a little bit of thought to possibly widening this out maybe another inch. So someone with slightly wider shoulders will feel comfortable. And that will actually help with streamlining if I move both of these corners out 1 inch. Well, let's find out what it's like to climb out of this beast. Let me take my helmet off. I'm going to unlatch it. I really like its one-hand unlatch. It comes off pretty easy. Now, what's it going to be like climbing out of this beast? So again, the position of the instrument panel is going to be critical to keep from hitting our knees. So let's give it a try. So I noticed that I always end up putting weight down here about where this cross member for the control stick is. So I'm going to have to make sure this bottom longeron is strong enough to hold the pilot's weight when they stand up. Then you stand up on the seat. And then step out on the wing. Well guys, this video is getting to be pretty long. So this part we'll just call analysis and we'll call it part 3A. And then for the next video, for the rollover test, we'll call that part 3B. Well guys, thanks for watching. Until next time.